This video is to go over the product rule. Now, the first thing you need to understand is that the product rule applies to the product of two functions. So some rules show it as the product of u times v, and u and v are just two different functions. Some things show it as f of x times g of x, and f of x and g of x are of course still just two different functions. So the way it works is that you do not take the derivative of u and multiply it by the derivative of v. The answer is not u prime v prime. So what we're going to do instead is look at the product of these two. So we have a first function, u, and then we have a second function, v. The product rule will be the first function, so u, times the derivative of the second, v prime, plus u prime times v. And you're adding them together. Now, the order here doesn't matter because multiplication is commutative, so it could be v prime times u, and this could be v times u prime. And addition is commutative, so these two could be switched. It doesn't really matter. For the quotient rule, which we'll get to next, order does matter because we have a subtraction symbol here. So it's first function times the derivative of the second plus second function times the derivative of the first in some order. So if I write it up for this one, it's first function f of x times derivative of the second, g prime of x, plus the second function, g of x, times the derivative of the first, f prime of x. Now you might wonder, do I actually have to use the product rule? And the answer is yes, if the problem requires it. So I'm actually going to start on this third example. F of x equals x times x squared plus 2x. So you can use the product rule here because I clearly have two functions multiplied. I have x times x squared plus 2x. I have a first function and I have a second function. The question is, do I need to do it? Well, no, because I can distribute this x into the parentheses, and if I just distribute, I would get x cubed plus 2x squared. So my derivative would be f prime of x equals 3x squared plus 4x. That's one way. Okay, if I try it with the product rule, I'll have f prime of x equals the first function is x times the derivative of the second, 2x plus 2, plus the second function, which is x squared plus 2x, times the derivative of the first. Well, the derivative of x is 1. So if I simplify this, I get, by distributing this x, 2x squared plus 2x plus x squared plus 2x. And you can see that if I combine like terms, 2x squared plus another x squared is my 3x squared, and a 2x plus 2x is 4x. So this problem could be done either way. Now the two problems up here, you don't have a lot of choice. So x squared can't be distributed into this x on side the cosine because that's just not how it works. X is the argument of the cosine function. So the key is to recognize that we do have the product rule. The answer is not 2x times a negative sine x. You're going to have to do first times derivative of the second plus second times the derivative of the first. Over here, I have the product rule right here. You can see the multiplication, x times cosine of x squared, and you can see that this is also the chain rule. I have a u. And then in my next term, I have the product rule again. So I could conceivably have 4 terms in my answer because when I start with 2 terms, like this, two things multiplied, I get 2 terms. So I have 2 terms here, or 2 functions multiplied, I'll get 2 terms, another 2 functions multiplied, I'll get another 2 terms, so I could have 4. So to actually work this problem, I'm going to say y prime equals, the first function is x squared, the derivative of the second is a negative sine x, plus the second function, times the derivative of the first. If I wrote this out a little bit cleaner, I'd say y prime equals a negative x squared sine x plus 2x cosine x, and that's done enough. Now, if I actually was solving for something, if I was trying to find where y prime equaled 0, I could factor out an x, and then I could work from there. Okay, for the second function, I have x times a cosine of u plus x times the natural log of x. So my derivative will be f prime of x equals, and I'm going to do this piece first. So first function is x times derivative of the second. I'm going to actually do it with the u in there. So it's times multiplied by negative sine of my u times my u prime plus, that's first times derivative of the second, plus second, that's just the cosine of u, times derivative of the first, that's a 1, plus, and I'm going to do the product rule again, first times derivative of the second, the derivative of the natural log of x is 1 over x, plus the second function, natural log of x, times derivative of the first, which is 1. So if I clean this up, I know that my u prime is the derivative of x squared, so if u equals x squared, u prime equals 2x. So my final answer will be f prime of x equals, and it'll be negative because of the negative sign of u. I have an x times a 2x is 2x squared, sine of my u, which is x squared, plus cosine of my u, x squared again, plus, if you look at this term, my x's cancel out, a 1, which I'll put at the end, plus a natural log of x. And you'll see that it has 1, 2, 3, 4 different terms in the answer. And that is product rule basics. We'll look at product rule numerically in a different video.